Everybody, Scoutcrafty here again. It's Fix It Friday. Well, I hope we can fix it. And today's project comes from a good friend of the show, Nathan Bear. Nathan's out in Las Cruces, New Mexico. New Mexico is the 5th largest state in the United States. It's cool about it, for a pretty square looking state. It has, like 5 borders to it. It's an amazing place. And Nathan had this great little jigsaw that was his friend's grandfather owned it. And it's a really cool little jigsaw, but he wanted to get it operating because when he opened it up, there was a problem. So let's go check it out. Now, here's the jigsaw in question. It's a nice little shop craft. It looks like it's probably from the late 50s or 60s. And you can see when opened up, it's there's a little piece that goes between the armature and the actuator of the blade. And you can see here, you see the crack on the lower part of that piece, and that's the piece that we're going to be working on. Now, here's the part in question. Now, when Nathan and I were talking and conversing about this, I asked him to send me some pictures, and he did. He sent me a whole bunch of pictures, but I thought it was much bigger than it is. And I had visions of trying to make this part in aluminum and then sleeving it with some bronze. Now, basically, this looks like it's made of a bronze, okay? And the reason they do that is because the bronze is a bushing material. Bronze is basically a copper tin alloy, and it's very good for making bushings because it doesn't wear so much on metals, and it has kind of a built-in lubricant, as it spins. So a lot of times things are made of bronze. So instead of them making just the 2 bushings, since this part is so small, I guess they made it from the whole entire part from bronze. So believe it or not, the hardest part of this is going to be this little lip up here to make, and you can see where it's cracked here. But what we're going to have to do is we're going to have to take some dimensions. Now, bronze is expensive. Even we were looking at some prices of bronze, and Nathan was able to find this piece from Grainger, and you could see here, it's you could see the size. We can hopefully get this out of here, and there's enough that I can make a couple mistakes. Hopefully I won't. And the one thing that it's important to remember is that when you're dealing with bronze, some things like this is a round stock of bronze, and usually much more available and cheaper than if you were to get a square piece, because for some reason that's just the way things run. It's what's available. So let's see what we're going to do. One really great aspect about being a machinist, which I'm not, and I have a great respect for people that do, is a machinist will look at this, and he'll look at this part, and right away they start thinking about what kind of operations they're going to do first. The whole idea is you always got to think of how you're going to hold this to do your certain operations. So obviously we have a piece of round stock. We're going to have to make it somewhat square, okay? So that's the first operation. We're going to have to cut the length of it. And you see, we're going to have to cut a length, then we'll square that off, and then we'll have to work on it slowly. So first we'll get it to this dimension here, and then we'll drill the holes because we can hold that dimension in the vise. Once we drill the holes, then we can take away these parts and make these little things. So, it's going to be a chore, so let's see what we can do. Okay, our first step was we cut it down with a hacksaw, and then we put it in the lathe to square off the ends. Now we're taking it over to the milling machine, and we're going to make a couple flat sides so we'll hold flat against the vise. Step number 2. Now, you see we squared this off so that we can hold it into the stock, but here we're going to take a measurement, and we got about 689 here, you see? 689, and we're going to put this over here, measure this one here, and you can see 689. So we're within the thousandths, which is nice. Now what we're going to do is we're going to put this in a vise, and we're going to transfer these holes, these 2 holes, down to this piece here, and then drill them out. Okay, remember I told you that we have these the same thickness. Now we put them in the vise here, we clamp them down. The backs are level here, everything is all level with here. So now we use these transfer punches to find out where the center of the hole is. That's the easiest way. We'll take the small one, put that up there. The larger one, you see they got these little dimples here that'll leave a hole. And then we'll put the big one there. And then we'll tap it with the hammer, and it'll leave 2 dimples on here where we could drill out these holes. Now there's our 2 dimples where we're going to drill out these holes. Now here's where the pin gauges come in to find out exactly what size. Another reason why a pin gauge set is really good to have. Now, by using the pin gauge set, we determine that the bottom hole is 375 thousandths, which is a nominal size. That's 3/8 of an inch. That's a very common size. I could see why they did that. The top size, however, is 313 thousandths. Not a very common size, so we're going to have to I have a reamer for this, and I don't think a reamer for this, but I'm going to check. And you know, you want to get the hole as close and as round as possible. That's where a reamer comes in. A drill bit doesn't really leave a round hole, but we'll do the best we can. Now, like I was saying before, bronze or brass is a copper alloy, and copper, anything that has copper in it, has a tendency, you got to be very careful, because the bits can grab and draw themselves in, and you can have a real nightmare in your hand. So you got to go very careful, and we go up in bit sizes. We start with a small bit and work our way up. Okay, not to get complicated here, but anytime you're going to drill a hole that you're going to run a shaft or something else, and you want a round hole. And unfortunately, drill bits do not make a perfectly round hole. If you look at them through a magnifying glass or something, you'll see they're kind of like almost like a triangular shape. It's crazy if you look at them through a microscope. But when you want to get something precise, what you have to use is something called a reamer. And this is a reamer here. And there are different types of reamers here. This one is a slant fluted. This is a straight fluted. But there's a whole bunch. But what a reamer does is a reamer makes a perfectly round hole. And you could see the flutes, the difference in them. And if you want to use, like for this bearing surface here, you want a ream surface. So we're going to drill it with a smaller drill bit, slightly smaller, and then we go in with the reamer. You don't start with a reamer. You can only take off a few thousand because of the design of the tool. But we're going to go to our drill set and pick out a proper drill. Okay, this is where it really pays to have one of these large drill sets that incorporate a whole array of sizes that you could use. Now, we want to do that 3/8 of an inch hole, but you have to ream it. Now, if you look here on the chart, 3/8 of an inch is 0.375 of an inch, okay? And now if we need something a little bit smaller. So the closest thing we could find here is this U-bit, and this U-bit is 0.368. So that's only 7 thousandths less, but it's enough that we can use that to drill in, and then we'll use the reamer to follow up. So like I said, it's got to be close, but it's smaller. Okay, here's my 3/8 inch reamer. It's a little bit rough, but it's still much better than the drill bit. And you can see I just did a little tip of the hole there, and that's the difference between the U-bit and the reamer. And you can see there that it's getting to be a much cleaner, nicer hole. Okay, we just reamed the hole. Before we take it out of the fixture or anything, we're going to take the pin gauge and see how it fits. This is the 3/8 inch pin gauge, the same one. And you can see, look at that. It's a beautiful fit. There's no play side to side. It's the same size hole as that one over there. Now we're going to try and get this one to 3/13. Okay, since we didn't have a reamer for this top hole, we drilled it out with progressive drill bits, and then we used a high speed for the drill and a low feed rate. So we got a real nice hole, the best we can get with a regular drill. And you can see this dowel pin that is the same one that was in the other one, fits really good. And I think this is exactly what we want. Now, for me, this was the most difficult aspect of this whole operation, getting that little lip around here. And here I'm using what's called a rotary table, and it goes on top of the milling machine. And what you do is you turn it, and it spins around kind of an axis. But this is really not the best way to hold it. You know, I have a 4-jaw independent chuck up there, but it got the job done. And, you know, like I said, it's a little cringeworthy for a real machinist. Okay, we're calling this project done. I have to tell you, this project was way harder than it looked. And I have it pretty much close to what it is. You know, the two little guides there that fit in. All the holes line up. This was a challenge, I'll tell you, and I hope it works, Nathan. If not, you can massage a little bit with a file or whatever, but all the dimensions should line up exact. I mean, they're all identical as far as size goes, so I hope this works out, because this was this was a chore. And I think any problem you might have with if it's a little tight or snug in here, it'll run in, because I left it's exactly like the hole sizes on each are exact the same as this one, so I don't think you'll have a problem. Unfortunately, we have a lot of noise pollution here in the city, but if you listen real close, you could hear the cicada in the background. And this is the time of year they come up. Amazing creatures. Let me talk a little bit about them. Now, it's hard to imagine that one of my favorite insects, the cicada, started its life off as an egg on a tree somewhere in the crack of a tree, and then it became a nymph and crawled down that tree into the ground, burrowed into the ground, and for up to 17 years just stayed underground, feeding on roots and things like that, and waiting for its time to come up. And then when it comes up, within 24 hours, it climbs a tree and then bursts out of its shell. Now, this cicada here is long since passed away. It's from my collection, but this is the type we have here where I live. And they're just beautiful creatures. I remember them ever since I was a kid. And what's amazing is, as long as they live underground, when they come up, they only live 4 to 6 weeks, and they're only here to mate, and that's it. And then they perish. So they've been around the world. There's over almost 3,500 species of the cicada, and I was just wondering if you have any by where you live.